Okay, so today is kind of a review of geometry. We're just going to learn how to solve right triangles. If you need to at any time, go ahead and pause the video so you can draw any of the pictures and then you can continue on. All right, let's take a little geometry flashback. First of all, a 45, 45, 90 triangle. You'll know from the unit circle that it's root 2 over 2. And again, if you take a look at Pythagorean theorem, first of all, 45, 45 is an isosceles right triangle. So you know the legs are going to be the same. And then the hypotenuse would just be the leg times root 2. So for example, if you want to solve for the missing sides, we know this is a 10. Well, that's the x root 2 part. So if you just solve 10 equals x root 2, divide by root 2, so 10 over root 2 equals x. Rationalize it, so 10 root 2 over 2 is x. Therefore, 5 root 2 has to be the x. Then you can easily solve for the sides. Since they're the same, they're both 5 root 2. For a 3069 triangle, the pattern goes 1, 2, root 3. 1 is the smallest number, so 1x should be across from the 30 always. Root 3 is the second largest number, and 2x is the largest number, so that's why it's across from the 90. So again, if you have the hypotenuse in the 3069 triangle, let's say that's 10, we know that matches up to the 2x side. So if you solve this equation, you have 5 equals x. The x is the one side, so this has to be 5. And the longer side has to be 5 times root 3. Okay. What does it mean to solve a triangle? Well, a triangle has 6 parts to it. You're going to be given 3 out of those 6 parts. So you just have to find 3 more. The first thing you're always given is a right triangle. So you know that this angle right there is always, it's going to be a 90 when you're solving right triangles. So to solve it just means to find all the angles and all the sides. Whatever is missing from the triangle, just fill it in. It's very important to label the triangle correctly. So sorry for the delay. Here we go. As I was talking about, it's very important to label the triangles. Unless they say otherwise, usually they label the right triangle as C, and just label one of the angles as A and the other one as B. Notice that angles are labeled with capital letters, so the sides will be lowercase letters. Here's how you label it. The side across from angle A will be baby A. Across from angle C would be baby C, and across from angle B would be baby B. It is very important to label the triangles accordingly. So for example 1, here we go. We have 3 things. 1, it's a right triangle. We know an angle and one of the sides. Always, always, always start by drawing yourself a picture so you have a visual. Let's go ahead and put the right angle at C, like so, and label what we know. So baby A is 25.3, so that's across from angle A. And angle B is 28 degrees and 40 minutes. If you don't remember how to do minutes and degrees, it's easy. I gotcha. Here we go. So obviously we have to find angle A, side B, and side C. Okay, easiest thing to do would be to find angle A. Finding angle A, since it's complementary to B, is just 90 minus angle B. Now, since angle B is in degrees, minutes, and seconds, we want 90 degrees and 0 minutes. That's how you'd write 90. And then just go 28 degrees and 40 minutes to have to subtract it from angle B. Now think of degrees as hours, and then how many minutes are in an hour? Well, there's 60. So in order to borrow 1 hour, so this becomes 89, then you can carry over 60 minutes to the other side. And I could just subtract. 60 minus 40 is 20 minutes. And 89 minus 28 is 61 degrees. So, filling in our triangle, we found angle A is 61 degrees and 20 minutes, like so. Okay, that was the first thing we found. Second thing, just going in alphabetical order, we need to find baby B. Now what I like to do with the triangles is I like to use the stuff that's already given. So we were already given the 2840 and the 25.3. Now in order to do the 2840, you kind of have to change it into decimals, and I'll show you how to do that. So to find B, notice that B is across from, little b is across from big B, and we have the adjacent. Opposite of adjacent is tangent. So if you go tan of 28 degrees 40 minutes, that's equal to B over 25.3. Just multiply the 25.3 to the side. Okay, and change minutes back into degrees. You just have to divide by 60. It's going to be a decimal. And you just tack that decimal on to that degree. So you're going to have 25.3 tan 28 point, like 6667, so 67 degrees is equal to B. And if you quickly just calculate it, because of sig figs, you only need one decimal place because that's all they were giving you in the original problem. You should get about 13.8 for B. So we filled this one in as 13.8. Okay. And last but not least, to find C, there's a third thing we have to find. Since we have two sides and we know it's a right triangle, just use Pythagorean theorem. You can use another sine, cosine, or tangent if you want to, but I mean, a squared plus b squared equals c squared equals, it works. Equals c squared. Yeah? So 25.3 squared plus 13.8 squared is equal to c squared. So if you do some work, take the square root, you'll find that 28.8 is what c is. As always, check your answer. 28.8 should be your biggest side since it's across from the biggest angle. And then the smallest side is 13.8 because it's across from the smallest angle. And that's how you solve a triangle. Let's look at this next problem. In this problem, the three things you're given is it's a right triangle. We have two sides. So if we draw out the picture, fill in what you know. We know side A is 44.25 and side B is 55.87. So the quickest thing to find is obviously side C. Since we have the two sides, to find side C, just use a squared plus b squared equals c squared. And you have 44.25 squared plus 55.87 squared equals c squared. You get 5079.5194 is equal to c squared. So if you square root that, you get about 71.27 is your c. That looks about right because that's bigger than all the other sides. There's one of them. Okay. I like to do these in alphabetical order, so the next thing I'm going to find is angle A. Now, notice that for angle A, we're given A and B. So if I use tangent, because it's opposite over adjacent, the tan of A is going to be 44.25 over 55.87. Make sure your calculator is set in degrees, please. Otherwise, you're just going to get radian answers. So to solve for A, you just do the inverse tan of 44.25 divided by 55.87, which gives you about 38 0.69 degrees. Okay, and then finding that last angle should be pretty easy. We know A and B add up to 90. So the third thing is number 2 right here. So the third thing to find angle B is just take 90 minus angle A. So 90 minus 38.69 is 51.31 degrees. There you go. Okay, now, it's all well and good for just numbers, but these are actually things you can apply in real life. And what's a school way to apply real life? Well, word problems. So, sorry about that. And we're back. All right, so here we go. Tackling a word problem. First thing, as always, it's the word problem, so you got to translate it into pictures. Make sure you draw a sketch and label it with your information, and then label the quantity to be found with a variable. Use the sketch to write an equation, and then solve that equation, and make sure to check either mentally or plugging back in that your answer makes sense. One application of right triangles is angles of elevation or depression. For an angle of elevation, you usually start from the ground and you measure the angle upward. So when you're measuring upward this, for example, if you're here looking at the sun, right? Here's the sun. If you're looking up at the sun, that would be an angle of elevation. If you were standing at the top of a cliff, let's say you're standing at the top of a building, right here, right? And then you are looking down at your friend down here. This right here would be the angle of depression, because you have to look down at your friend, right? Well, if you think about it, you got right triangles, and since they're alternate interior angles, then your angle of depression would also end up over here, because alternate interior angles are congruent. Okay, so for example, from the top of a tree, so a point on the ground, we're trying to find the height of the tree. Okay, so again, draw pictures, and I like to draw realistic pictures. So here's the tree. Okay, so there's some point on the ground that's away from the tree. So from the top of the tree, right here, there's a point on the ground that's 15.5 meters away. And it gives you angle of depression, so that's from the horizontal, you're looking down, this is 60.4 degrees, so therefore this angle has to be 60.4 degrees. Of course, you've got this right triangle. I'm trying to find the height of the tree. So your variable h is perfectly acceptable for height. Take a look at what you got. You have the opposite, or you're looking for the opposite, but you have the adjacent from 60.4. So that would be 10. 60.4 is equal to h over 15.5. Multiply 15.5 to the other side. And solve. You should get about 27.3 meters is your height. Okay. Flagpole problem. Good luck. The length of a shadow of a flagpole that is 55.2 feet tall is 27.65. So, yeah, there's some word issues here. The flagpole is 55.20 feet tall. The shadow is 27.65 feet. So, realistic pictures. Flagpole. And shadow. There you go. We know the flagpole is 55.20. We know the shadow is 27.65. Find the angle elevation to the sun. Right there. So we're looking for that angle. Okay. So again, we have tangent is equal to opposite over the adjacent. Like so. So to solve for theta, just take the inverse tan. And that'll give you about 63.39 degrees. Hope you have fun with right triangles. I know I do.